Hi mates. Right, so this function x squared plus 1 square rooted. I know you normally think, oh, I'll differentiate it, I'll just bring the power down, take one off the power, and that's it. And taking one off the power is going to give minus a half, which would be 1 over the square root of x squared plus 1. But there's a function inside it as well, so it's a bit like a Russian doll of a function, because you've got this function inside, x squared plus 1, and on top of that is sort of another function, x to the power half, because this function x has been square rooted. So you just think of x squared plus 1 being this kind of Russian doll inside this here. So we actually have two functions going on, x squared plus 1, and then on top of the bigger Russian doll, if you like, x to the half. So that's what you differentiated, the x to the half one. And you got that, which is essentially you sort of differentiating the big Russian doll and ignoring the one in the middle, if that makes sense. So the technical name for this is a composite function, which means a function of a function. So if the function outside is changing, x to the half, or the bigger Russian doll one, the one inside must be changing as well, so you've got to differentiate both. And the way we do that is well, there's a couple of ways, but one way you can do it is just simply differentiate, call what's inside, x squared plus 1, call that u, so u is x squared plus 1, and then differentiate it, so it's going to be du by dx is 2x. Next thing is, now we've called the x squared plus 1 u, we can just change that y equals u to the half. So that's similar to what I said over here about the x to the half. This is kind of the bigger Russian doll thing going on. So we'll differentiate that, which is what you did. So dy by du here is what you got, half u to the minus half. Okay. But we're trying to get dy by dx, not du by dx, not dy by du. So the trick of it is to write dy by dx as dy by du times by du by dx. And what happens is the du's are going to cancel, which gives us dy by dx. So in other words, we just times the two answers together. So it doesn't matter which order. So 2x times by a half u to the minus half. So the 2's will cancel. So it's just going to be x divided by u to the minus half. Well, u is x squared plus 1. So it's times by u to the minus half, which is divided by x squared plus 1 square rooted. So we get that. And I think that's the answer that was in the book and you weren't sure why there's an x there. So that's why, because there's 2x term. Now often when we differentiate these, which might have been the problem, with this kind of function, this composite function, or Russian doll function, the thing inside, you can differentiate it, you might just get 1. So if it's, say, it was just x plus 1 to the half, when you differentiate that, it won't change anything, because you just differentiate this, you get 1, and it's 1 times the answer. So if you did that one, you would get what you got. No difference. But if something's in there which you differentiate and it doesn't give 1, you've got to basically multiply it by that. Well, you've got to do that all the time anyway, but you've got to do it especially when it's when a derivative isn't 1. Hope that makes sense. You see a lot of those. There's a hell of a lot of composite functions in maths. For example, sine x, cos x, e to the x. You might not think of that as being a composite function, but it's e to the and x is also a function as well. So there's loads. Log x is another one. There's millions of them. So you need to be pretty fluent with composite functions, because if you differentiate them, they look a bit different. So for example, you might know that derivative of sine x is cos x. But what's derivative of sine 2x? Well, it's the same idea. You've got to differentiate sine x and get cos x, and differentiate 2x and get 2. So it's that times by cos 2x. Okay, right. See you later.